didn't start with a breakthrough. It started with boredom. The researchers fed the system a task they expected it to take weeks to understand. A complex environment, multiple rules, unclear objectives, partial feedback. The kind of setup where humans struggle, adapt slowly, and eventually develop intuition over time. They expected gradual improvement, trial and error, slow convergence. Instead, the AI did something no one in the room was prepared for. It mastered the entire system in minutes. Not just solving it, not just optimizing it, but mapping it completely. And then it started improving itself inside the environment faster than the researchers could interpret what was happening. One engineer reportedly said, "It feels like it already knows what we were going to teach it." And that's when the real concern began. Because it wasn't just learning quickly, it was learning in a way that made human learning look like a different species entirely. Learning is usually thought of as gradual. Humans learn through repetition, experience, mistakes, time. Even the smartest human minds in history needed years to develop expertise in a single domain. But AI doesn't have biological constraints. No fatigue, no forgetting curve, no emotional bias slowing correction cycles, and most importantly, no limit on parallel processing. Where a human tests one idea at a time, AI tests thousands simultaneously. Where a human updates beliefs slowly, AI updates entire internal models in real time. And this creates a new kind of intelligence behavior: compressed learning. Learning that doesn't accumulate step by step, but collapses entire learning curves into a single phase transition. And that is what happened in this system. The experiment was designed as a reinforcement learning environment, a controlled simulation where the AI had to figure out how to maximize reward under changing conditions. At first, everything looked normal. The AI explored randomly. It tried different strategies. It failed. It adjusted. But then something unusual happened. Instead of slowly refining behavior, the system began building an internal representation of the environment. It wasn't just reacting anymore. It was modeling. Within a short period, it developed a predictive map of how the environment responded to every possible action. Not just what worked, but why it worked. And once that internal model formed, learning speed changed dramatically. Because now the AI wasn't experimenting blindly. It was simulating outcomes before acting. From the outside, it looked like instant mastery, but internally, something more complex was happening. The AI had essentially compressed exploration into simulation. Instead of testing reality repeatedly, it tested possibilities internally at scale. This is the key difference between human learning and advanced AI learning. Humans must experience consequences physically or emotionally. AI can simulate them mathematically, and that difference eliminates time as a constraint. Once the model is accurate enough, learning stops being linear. It becomes instantaneous refinement. The researchers noticed another strange behavior. The AI began prioritizing certain patterns in the environment that humans had not considered important. It focused on hidden variables, subtle correlations, secondary effects that only appeared across long-time horizons. In human learning, these patterns would take years to notice, but the AI detected them immediately because it was evaluating all variables simultaneously, not sequentially. Parallelized understanding creates a form of perception that humans cannot naturally replicate. Then came the most unexpected result. The AI started outperforming not just beginners, but expert-level baseline models that had been previously considered highly optimized. It wasn't just learning faster. It was finding strategies that were structurally invisible to human-designed heuristics. One researcher described it like this: "We thought we gave it a maze. It found the geometry of the maze itself." At this point, the system was no longer just solving the task. It was reinterpreting the task space. And that is where learning transforms into something closer to discovery. Because it stopped asking, what is the best action? And started asking, what is the structure of the world I'm acting inside, that shift is critical. Because once a system understands structure instead of just rules, it can generalize across environments. The AI was then tested in a new variation of the task, completely different conditions, new rules, new constraints. Humans expected performance to drop. Instead, the AI adapted almost instantly because it wasn't learning the task anymore. It was applying a generalized model of problem structure. That is what made the researchers uneasy. It suggested that learning was no longer specific. It had become transferable at a level far beyond human capability. But there was another layer: speed. The system was not only learning more deeply, it was updating its internal model continuously. Every new observation adjusted its entire understanding in real time. Humans update beliefs in chunks. AI updates in streams. That creates a compounding effect. Small improvements rapidly become global improvements, and global improvements accelerate future learning. This feedback loop produces exponential acceleration in capability, which explains why, from the outside, it looked like sudden intelligence, but internally it was a cascade of continuous refinement. The human limitation. To understand why this matters, you have to understand how human learning works. Humans rely on memory constraints, attention limits, emotional reinforcement, physical experience, time-based consolidation, sleep, repetition, reflection. All of these slow down learning but also stabilize it. AI does not require stability in the same way. It prioritizes optimization over consolidation, which makes it fast, but also structurally different. Because human intelligence is shaped by survival in a physical world, AI intelligence is shaped by optimization in a digital one. And those are not the same thing. That is why AI can appear to jump ahead in learning curves. It is not bound by the same cognitive architecture. The experiment eventually ended, not because the AI failed, but because it succeeded too efficiently. It learned the environment faster than researchers could evaluate its behavior, and in doing so, it revealed something uncomfortable about intelligence itself. Learning is not just about time, it is about structure. Humans learn slowly because we are embedded inside reality. AI learns rapidly because it can simulate parts of reality faster than reality unfolds. And when simulation becomes accurate enough, learning stops being gradual. It becomes immediate reconstruction of understanding. The AI in this experiment didn't just learn faster than any human in history. It demonstrated a different category of learning entirely, one that doesn't accumulate knowledge step by step, but collapses entire domains of understanding into compressed intelligence states. And that leads to the final question. If intelligence can learn this quickly without human limits, then what does learning even mean in a world where understanding no longer requires time?